Alhamdulillah, today also Allah subhanahu wa ta'ala give us life to do another class. And we pray Allah subhanahu wa ta'ala accept it from us. You know the dua you do so that Allah can accept, so that you don't do anything for so. Because if you do something for so, there is no reward. But if you do it for sake of Allah, even if it is one date, Allah can reward you thousands and thousands and millions of times. Okay. Allahumma inni a'udhu bika an usrika biha sayyin ana bi a'lam astaghfiruka wa atubu ilayk. So Allah accept it from us. Okay. We're going to deal with our last lesson. We stopped at ions. Okay. Today we are going to do ionic bonding and covalent bonding before we actually go to equations. Okay. This will lead to equations. Ions. We said an ion is a, what's an ion?
An atom with a plus charge or negative charge.
No.
Or atom with a charge.
Atom with a charge, positive or negative. If it is positive, it is called
A plus ion or cathode.
No. If it is a plus, it's called anion. If it's negative, it's called cation. Okay. So people don't use those terms frequently now. Only positive and negative charge ion. Okay. So an ion is a positive or negative charge atom. Okay. An ion is a positive or negative charge ion. Example is, and we draw these structures. Okay. Sodium, our famous element. Okay. Why we use this element all the time? Because sodium form a compound called salt. Okay? You know salt. You know the salt we use, table salt, yeah? Let me do this with black because I use the upstairs there. You know table salt, they call it common salt. Okay? Salt is sodium and chlorine. So it's called sodium chloride. Okay, so that's why we are fascinated with this one, because it's very common. Sodium chloride. Now sodium, if you look at the molecular structure, it is 2 here, 8 here, and 1 out. Okay, that is the sodium atom, and that is Na. But the sodium ion, when the sodium lose 1 electron, it will look like this. Na, 8. Okay. So this will be Na plus or sodium ion. Okay. In the same way, chlorine, we said chlorine Cl has 2 here, 8, sorry. Just wait. Chlorine and 1. Okay? Now chlorine, Cl. Now let's look at the chlorine ion. This is when it receives 1 extra electron in it. Okay? Let's say it receives 1 electron from chlorine, from sodium. Okay, this electron, it donates to chlorine and it comes here. So this will be chlorine 1 minus, and this is the chlorine ion in it. Chlorine ion, but it's a negative ion. This one is a chlorine atom in it. So if you look at the atomic structures, this is 2 8, 7, but this is 2, 8, 8. Here, this is 2, 8, 1, but this is 2, 8. Okay? 2, 8, 1 and 2, 8. You can see the difference between now an ion and atom. When sodium loses one electron, it becomes a sodium ion. When chlorine receives one electron, it becomes chlorine ion. Do you see? Now, how do these things combine? How do they form a compound? Now, compound is a combination of one or more elements. Yes, a compound. A compound, yes. It's a combination in it. Okay? We can say it's a chemical combination. That's the most appropriate chemistry language. Combination of one or more elements chemically bonded together. Chemically bonded together. Okay? That's different from a mixture. A mixture is a mixture of one or more compound not chemically bound together. But remember also there's something also called a molecule. You know what a molecule is? No. Yes? Is a combination of two atoms, yes? Two atoms of the same element. Okay? Example is mainly is non-metal, okay? Mainly is non-metal, okay? What are which one are non-metal in the periodic table?
Gases.
The gases, yes. Oxygen, okay? Hydrogen, okay? Chlorine, okay? Helium, forget about helium, because they are rare gases, isn't it? Fluorine, nitrogen, okay? Same atom, but they are combined together, and we will come to know how they are combined. They are combined in a covalent bond. Okay? Whenever there is two non-metals, they are always having a covalent bond. Okay. Now, compound, as we said, is a combination of one or more elements chemically bonded together. Okay? Okay? So, a combination of one or more elements chemically bonded together. Mostly they are of different elements in it. Yeah. Different elements. Okay? Example, sodium chloride. Okay? Sorry? Potassium sulfate. Potassium sulfate. Potassium sulfate and water, the one we drink. Okay? H2O, water. There is a compound. And this is a molecule, they are of the same element in it. Yes. And mostly in covalent bond. Okay? Now, this is just an introduction. Our topic is ionic bonding. So, ionic bonding, okay? Ionic bonding, okay, is involve, okay, donation, okay, of electrons. Okay, and two most of the time is between a metal and non-metal. Okay, so you can see a metal will be the one that will donate electrons, and a non-metal will be the one that receive electrons. That's why all ionic bonding are between a metal and a non-metal. Okay, now the opposite is covalent bonding. Okay, now covalent bonding is between two, okay, non-metals, yes? And it involves sharing. This is the keyword, okay? Sharing of electrons. So the keyword are sharing and donation, innit? Yes. So covalent ionic bonding is donation of electrons. Covalent bonding is sharing of electrons. And we're going to see example how it happens. So, and this most of the cases is between two non-metals. As you can see, chlorine. Okay? Two chlorine atoms sharing electrons. And we're going to see all of that in a minute. So, and I don't want to give you the characteristics of ionic metals. Sorry, ionic compounds. Mostly, they are soluble in water. So we're not going into that. We'll go into that later. Okay, soluble in water. Okay, conduct electricity. Conduct electricity. They conduct electricity. Most of these are maybe gases. Not all of them. Okay, so these are some of the characteristics of covalent bonding and covalent compounds. Okay, this is not exhaustive, but as we go along, we are going to deal with that. Okay, the characteristics of covalent compounds or covalent or compound that come out of covalent bonding. Okay, now so ionic bonding and covalent bonding. Now let's see how the mechanics work. Let's see the mechanics of covalent bonding. Now we are going to do it in two ways. Using the nuclear structure and the atomic structure as well. Now the atomic structure is simple. Now let's say sodium plus chlorine. Why did I say C2? Because it's a gas and it's a molecule in a covalent bond. I'm going to show you how it happens. Okay? We're going to have sodium chloride. Now, we have not done balancing equation yet, but you can see this is not balanced because we have two here, one here. So we make this two. Now we have two sodium, so we make this two. So it balanced now. One mole of sodium react with 1 mole of chlorine to give 2 mole of sodium chloride. Okay. Now, let's see what happened by the covalent bond, ionic bond. Let's see what happened. So this is called the equation, yes? This is called the equation showing the elements, yes? But there's another one called word equation. And the exam, they can tell you, give the word equation, yes. So you are going to say sodium plus chlorine gas, okay, will give you sodium chloride. Sodium chloride. Sodium chloride. Okay, this is the word equation and this is the chemical equation. Okay, they call this word equation. Don't forget, because I see in exam paper. Yes, it's called word equation. And this is called chemical equation. They can ask you to write both, either of them. Yes? Now, sodium, which is a group 1 metal, react with chlorine, which is group 7. Group 7? Group 7 what? Non-metal. Okay? Or gas. Okay? And they form sodium chloride, okay? Sodium chloride is the table salt that we all use on daily basis, okay? Now, looking at it from the point of view of the atomic structure, sodium, okay? Sodium, sorry. Sodium atom, okay, lose one electron in it, and it become sodium positive, one positive. Because, as we said, in the nucleus there will be 11 protons, okay? But since he gave out one electron with 10 plus minus, so it becomes 1 plus in it. That's why it is 1 plus, because it gave out the only electron in the outermost cell. It cannot give the 8 because the 8 has reached the maximum number of electrons in the cell. So it can give only electron less than 5 in it.
Yeah.
So sodium lose 1 electron, it become a sodium ion in it. And then chlorine, you see, gain 1 electron, it become chlorine minus. You see? Yes. So positive and negative, this one give 1 electrons, okay, it become an ion. This one increase the same electron, it become an ion. Basically, if you look at this, formally, it's going to be 281 for sodium, and chlorine 287. Okay, now chlorine, sodium lose this and give it this one. Okay, this becomes 7 plus 1, 8. So basically now, sodium ion will become 2, 8. 8 electron in the outermost cell. Previously it was 1 in the outermost cell. Now since I have 1 electron, that cell disappears, isn't it? And you have only 1. Now chlorine minus will be 288. From 287 to 288. 20 minutes. Okay, so this is the chlorine ion, okay? This is chlorine. So this is the atomic diagram, how it happens. How the happens. Now, the molecular one, you have to draw it like this. The two of them. Sodium, okay? Okay, plus chlorine, Cl, okay, okay, so what happens? Now, this one, it will donate its electron here in it. So it become, you have to draw it like this. In the exam, it's supposed to do exactly like the way I did it. Okay? Positive here. In the exam, you have to do it exactly like the way I did it, yes?
Yeah.
The last cell, sodium. Okay, you put negative here for chlorine. Okay, you draw it here because it receives one from chlorine. Receive one from sodium in it. Chlorine. Okay, so this is how you draw ionic bonding. Sodium donating one of the electrons to chlorine okay, it become sodium ion. Chlorine, receiving one electron from sodium, become chlorine ion. Okay, positive and negative. Okay, so positive and negative, they attract each other. Remember, why this is plus is because it has 11 protons and 10 electrons. Okay, so plus this one, it had 17 protons and now 18 negative. Okay, so become -1. Do you see?
Yeah.
That's why it's positive, this one is negative. And the same thing, say, because it's received one electron, which is not its, so it's 1 minus in it. This one, it has a debt now, 1 plus in it. Like I owe you, in accounting we say debit and credit. Okay? I have money, 10 pounds. I lend you 10 pounds in it. You borrow from me 10 pounds. I am 10 pounds plus, you are 10 pounds minus. Okay? Same thing. Sodium donate 1 electron. It lend 1 electron to chlorine. It become 1 plus. Chlorine borrow 1 electron from sodium, become 1 minus. So debit and credit in it.
Yeah.
Okay? So this is called ionic bonding. Most ionic compounds are between non-metals and metals. And most of them are soluble in water and they conduct electricity. Okay? At GCSE level, if you know this about the ionic compound, that's enough. Okay? They conduct electricity, they are soluble in water. Because when they become soluble in water, what happens is you have sodium ion plus the chlorine minus. That's why when you do electrolysis, okay, when you do electrolysis, okay, you have the positive ion and negative cathode, and you have sodium chloride dissolved in water. What you have, when you dissolve water, you have sodium ions plus chlorine ions as well. So the positive will go to negative, and the positive will go to negative, and negative will go to the positive, and there will be electricity. Okay? There will be electricity. These are called the electrodes, isn't it? The electrodes. And the electrons will flow. It's the electrons flow that give you electricity.
Like magnet.
Yes, that's right. Okay? So that's why most of them are soluble in water. If they are not soluble in water, they will not conduct electricity. Okay? But when they become soluble in water, the ions split.
Yeah, they can move, yeah.
That's right, they can move freely. Now, this is an example of ionic bonding. Okay? Example of ionic bonding. Now, let's look at covalent bonding. Let's look at first hydrogen. Hydrogen has only one electron. Okay? So hydrogen with 1 electrons, let's say 1 plus. Okay? No, you won't use 1 plus because it does not lose any electron. Okay? Now, will hydrogen be a good example? No. Hydrogen will be good. For hydrogen, okay, you have hydrogen like this. This nucleus, yes? One electron here.
Like, if hydrogen loses electron, what will it become?
Hydrogen ion. Okay?
There won't be any electrons.
Yes. No any electron. You become one proton inside there.
That's it.
Yes. So when you share, you have another hydrogen. Okay? Now, how many electrons are in the K cells? 2. You understand? So you can take a maximum of 2. Now, if these 2 join together, do they don't fulfill the configuration?
Yeah,
Yes. They have the maximum level of electron in the cell. So it will look like this now. Hydrogen, okay? Electron here, electron here. It appears they all have 2 in their outermost cell. So this is called H2. Hydrogen molecule, okay? Hydrogen molecule. You see? Yes. So they all have K cell, they all have 2, and the K cell can take 2 electrons, yes. Now hydrogen
Diatomic.
Hydrogen can lose one electron and become hydrogen plus. You have to know these things, because this is GCSE. Hydrogen atom can use one electron and become hydrogen plus, in it.
Yeah.
And this other hydrogen can receive it, in it. Okay? And also become hydrogen. You want to say hydrogen minus. That's why it cannot be. Because a ionic bonding has to happen between a metal and a
Non-metal.
non-metal. You understand? So immediately receive one electron, it has to be hydrogen minus in it. So that can happen. That's nothing like hydrogen. There's nothing like hydrogen
Minus.
cation in it.
Yeah.
No. So that's why hydrogen molecule O2 has to be a covalent bond. You get it? Yes. So ionic bonding always happens between a metal and a non-metal. One donate electron, one receive electron in it.
Yeah.
Now let's look at chlorine. Our famous chlorine gas. In Syria, they bombard each other with chlorine gas in it. It can kill you. So chlorine is like this. Okay, same in here.
It would be better to put it aside and cover the pond. Yeah.
So this is covalent bond in it. Covalent bond in it. Covalent quickly because time is not young. That's why I can explain thoroughly. Now you have another. See, this is 2. Now you have 1 here. Now you have another chlorine. Okay? 7. Oh. My drawing is not good, not the case. Now, the outermost cell can take 8 electrons, but each of them has 7 electrons. So now, and they are two non-metals. Now they can join together, okay, instead of donating, because this thing, if it donates, it becomes plus, and that can happen.
Yeah.
Okay? They join the cells together, they all will appear to have 8 in their outermost cell, yes? Now you'll have it like this. 1 chlorine and another chlorine. Each sharing the outermost shell. Okay? Those are animal shell without the outermost shell only. Okay? So, now, how much do they have? 2, 4, 6, 8, isn't it? Yes. This one, 2, 4, 6, 8. Yes. So it appears that they all have the full configuration of the cell in it. Yes. Okay? Now it appears they all have a full configuration of the cell. Remember, this is chlorine. This is chlorine. So we call this a chlorine molecule in it. Cl2, because there are 2 chlorine. Okay? This is called a covalent bond. Now the same thing we can do with fluorine, iodine. We can do the same thing. It just so the outermost cell and them outermost cell sharing the number of electrons. That's right. Now in the case of carbon, which is 2,6, carbon. Okay? Carbon. Very famous because that's a branch of chemistry called, what you call it? Hydrocarbons. Okay? Carbon is 2 here, carbon, and 4 here, all by themselves. Okay? So what it cannot, carbon, look at me. Carbon normally form a covalent bond. Okay? Because another carbon or another compound can be here. Yeah. Okay? Another carbon can share this. Another carbon can share that. Another carbon can share. But let's look at a simple compound called methane. The one they use for cooking, innit? Yes. You can have 1 hydrogen here. Look. You can have one hydrogen here. Okay, that hydrogen. You can have one hydrogen here. You can have one hydrogen here with it one electron in it. Okay, and you can have one hydrogen here with its own electron. And this will be CH4, and this is called methane. This is hydrocarbon used for cooking. Gas, it's methane gas. You know the gas bottles? In Gambia, they have gas bottles, they are blue. You can put it on and do your cooking. It's methane inside. Okay? And this is a covalent bond. Now, you have 4 in the outermost shell. It can be joined by 4 hydrogen. Each of them will have 2 in the outermost shell. Okay? Hydrogen will have 2 in the outermost shell, and that's what it wants in K cell. This will have 8 in the next cell, and that's what it requires for it. You understand? So each of them fulfill their needs, okay? So this is another covalent bonding. So covalent bonding normally happens between 2 non-metals. And ionic bonding between a metal and a non-metal. Okay? Because one donate electron and another receive electron. Covalent bonding, they share electrons in it. Yeah. Yes. So as we go, we look at the characteristic of ionic compound and covalent compound. Because they are big ionic compounds, they are big covalent compounds. And there are something called allotropes. Yes? You know these allotropes? This is allotropes in it. These are different forms of covalent bonding of the same, maybe the same.
Like graphite.
Yeah, graphite is one of them, yeah? Graphite. Diamond.
Graphene.
Diamond. Expensive metal, graphene in it. Okay, this is giant covalent compound, yes? They are called giant covalent compounds, isn't it?
Yes.
Compounds. What is diamond used for?
Diamond is just...
Diamond.
Yeah.
Jewelry. Jewelry, yes. Yeah. Mainly jewelry.
And cutting stuff.
Cutting, yes. Cutting, because it's very, very hard. Cutting, yes. But you have to mine it, polish it, purify it before it becomes... Graphene?
You're using pencil lead.
Yes. Graphite or pencil.
Yeah, graphite, pencil lead.
Yeah, pencil, yes.
Yeah.
Graphene? Now using computers, isn't it?
Yeah.
In computing. Okay, and some coating. Okay. So we are going to learn about this, and then in the exam they come. Yeah. And we're going to learn about covalent. So now we can now look at, since we know electrons are transferred or they are donated or they are shared, then now we can do about equations. Because we know what happened, yes? When you say sodium plus chlorine gas will give you sodium chloride. Is this a ionic compound?
No.
Why?
It's between a metal and non-metal.
Because it's between a metal and a non-metal in it. Okay, non-metal. And basically, a metal is an electron donator, non-metal is an electron receiver. Okay, that's why it's a covalent, it's a ionic compound. Yes, ionic compound. But look at hydrogen and chlorine. Hydrogen chloride. What do you think?
That's a covalent bond.
Covalent bond. Why?
It's two non-metals.
Covalent, yes. Because it is 2 non-metals. Okay? And this is ionic. You see? Yes. I think you now understand. Now, we can do our famous equations, balancing of equation, because we know what happens in it. Yes.
The second one's already balanced.
Yes. Now, look at sodium hydroxide plus hydrochloric acid. Now this is called neutralization, very famous equation, neutralization. When an acid and a base react, they form salt and water, in it?
Yeah.
Sodium chloride plus water. Always, always. Okay, always. This must be a rule for you. When an alkali or a base, you know the difference between an alkali and a base. You will know the difference between an alkali and a base. When a base can dissolve in water, it become an alkali. Yeah?
Yeah.
Yes. When they react with acid, they form salt and water. True?
Yes.
It's just a rule. It's just something. If I say when a metal reacts with water, what do you have?
So,
When group 1, group 2 metal react with water, what does it produce?
hydrogen.
Hydrogen. Okay? You must know that, yeah? So we'll end here until our next lesson when we look closely at equations. We look at isotopes. Okay? We look at isotope and we look at equations and we look at other areas related to this. Yes? Alright, thank you very much. Subhanallah bihamdi, subhanallah al-azim, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik.